This video is an introduction to conic sections. Perhaps you know and perhaps you don't that conic sections, or just conics, are created by a plane that intersects a double napped cone. And we have already studied all of these in other classes, so they should be somewhat familiar to you: the circle, the parabola, the ellipse, the hyperbola. Obviously we've used the circle and parabola most often, but we should be familiar with each of these. Now, it's important to understand that you could write each conic using a general equation, which I've written for you, but that's not the way that we're going to represent these, because we want to use a more useful function, the standard form for each one. Those forms will help us to graph them or determine different characteristics of each of the conic sections. So in this video, I'm not going to take you through any calculations at all. This video is mostly so that you have access to all of the formulas all in one place for each of the conic sections, and that you understand each of the parts. So for instance, the circle, we're not going to really study the circle. It's the easiest one. X minus h quantity squared plus y minus k quantity squared is equal to r squared, where the center is hk and the radius is r. I didn't even give you a picture of that because obviously that's easy. Now, dealing with a parabola. A parabola is something we've used quite often. We probably did not have it in this standard form, however, and so that might be something to get used to. Now, the picture that I have for you relates to a vertical axis of symmetry parabola, which means the axis of symmetry is that line where I could fold the axis in half, whereas the second set of values has to do with a parabola that would either open to the right or open to the left, either one. Other parts of the parabola that you should be familiar with, we just talked about the axis of symmetry. The directrix is a line, and this is maybe something you've never seen before or you didn't understand. The directrix is a line that is the same distance from the vertex as the focus is from the vertex, and every point on our parabola has the same distance from both the focus and the directrix. So that's why they exist, is because every value is going to be the same distance. And then the latus rectum goes through the focus of our parabola, and it is perpendicular to our axis of symmetry. Again, each of those equations or measurements are here for you on this page for you to refer back to easily. Looking now at the ellipse, I hope you can see that the equation looks really similar to that of a circle. So remember, the equation of a circle was x minus h quantity squared plus y minus k quantity squared is equal to r squared. And so the big difference here is that if I have an ellipse with the same a value and b value, it's really just a circle. So the reason I bring that up is quite often they're going to give you something that looks like this, or say they give you a value over here that's 16 or 9 or 7 or whatever, and you would have to then determine, okay, is this a circle or is it an ellipse? And an ellipse, the biggest thing is that A is going to be greater than B. So if A were equal to B, it would be a circle, and if A is greater than B, then it's either an ellipse with the major axis on the x-axis or with the major axis on the y. So I'm going to get rid of all my markings because I want to make sure I keep it nice and clean for you to refer back to, but I will keep the A is greater than B because that's important. So what else do we need to know? The equation for an ellipse, again, looks like that of a circle, except that it's equal to 1. Wherever the A value is, wherever the larger value is, that's where your major axis is going to occur. So notice on the first one, my A is below the x, and the major axis is on the x-axis, or parallel to the x-axis. And for my second, the larger value is below y, and so it's going to be vertical. The vertices are the endpoints of the ellipse, and that is found differently for whether it is a horizontal or vertical major axis. And then it's sort of just the opposite for the minor axis endpoints. and then you have the foci. And again, the foci, just like on our last example, would mean that any value would be the same distance between the two foci. The sum of those distances is the same. So that's everything in a nutshell that you need to know about an ellipse. And the last is the hyperbola. Again, the center is HK. And the fun thing about a hyperbola is that it's really just an ellipse that has been cut in half and split open. So an ellipse would look like this, whereas the hyperbola cuts it in half and puts those arcs outward instead. So you have the equation, and the difference here, of course, is that the equation includes a minus instead of a plus. And the other difference is, because it's minus, the order of the values matter. So if you have the x first, then that means it's going to be a horizontal transverse axis. If you have the y first, it's going to be a vertical transverse axis, and you can see how that changes your pictures down here. And then again, I've given you the equations or calculations that you will need to find the vertices, to find the foci, and to find the asymptotes. You might be thinking right about now, hold on, she didn't actually teach us anything, and that is true. Again, the focus of this video was to give you all of the information that you need in one video very quickly, and now we're going to take a look at each of the conic sections in much more detail, with the exception of the circle. We are not going to cover that in any more detail. So up next, let's take a look at parabolas.